Hello everyone, welcome to this video. In this video we are going to discuss the various high availability features on Huawei's firewalls. As you understand, high availability means when you have redundancy in your network or when you have fault tolerance in your network. That's what we call high availability. So let's take a brief look at what are the few features that are available on Huawei's firewall for high availability. As you can see, this is the list of features that we have. We can have a feature called IP link, we can have BFT, we can have hot standby, link group, and Ethernet trunk or ETH trunk. These are the different high availability features which are available on Huawei firewalls. Let us discuss these features one by one. So first we will be discussing the IP link feature. The IP link feature enables us to detect the connectivity of a firewall with certain link or with certain IP address, and what the firewall does is that it periodically sends probe packets to a specific destination IP address, and if the response packets are received by the firewall knows that that particular IP address or that destination IP address is reachable and the connection is there. However, if the response packets are not received from that destination because of that IP being down, that device's interface being down, or one of the links being down, then the firewall would know that the link is down, and therefore it can take appropriate action to maintain high availability within the infrastructure. What action it takes, that depends upon our configuration. Whatever we configure on the firewall can take appropriate action. And once that link or that particular IP address becomes available again, the firewall can then again start sending traffic through that particular link. Normally what happens is that firewall sends probe packets every 5 seconds, and the timeout is 15 seconds by default, which means that if 3 packets are dropped or for during 3 intervals no response is received, then the firewall would consider the link as down or consider the destination as down, and then it can take appropriate action. So the purpose of IP link is to have an automatic detection mechanism to check the service availability of any particular link. So it can detect the status of the links that are indirectly connected to a firewall to ensure service continuity. Since it is only checking the IP connectivity of the destination, it can check for the indirectly connected links as well. So IP link feature can use either ICMP or the ARP packets for detecting the connectivity of a particular IP address, destination IP address. So if it is using ICMP, then it can check the connectivity of indirectly connected destinations, and if it is using ARP or address resolution protocol, then it can check the connectivity of directly connected interfaces. So for example, here you can see in this topology that this is the firewall, and it wants to check the availability of this particular link that is connected to the gateway router, so that if this particular link or this particular path is not available, then the firewall can move the traffic or can forward the traffic through the second router. So it implements IP link feature, and as soon as it detects that this link is not available, it can appropriately start forwarding traffic through this router or through this particular gateway out of this particular network. The configuration of IP link involves, if you go to system, you go to high availability, you click on IP link, you enable the IP link function, and then you create a new IP link or add a new IP link. Once in this window, you give the name to this IP link, and then you configure the destination IP address and the mode, whether ICMP or ARP. By using this configuration or by following this mechanism, you can configure the appropriate IP link configuration and create an IP link of your choice. Now IP link can be used in 3 different scenarios, for example. So there can be 3 situations where you can use IP link. For example, in the first scenario, which we just discussed as well, the firewall can check the connectivity with any of the IP addresses through one path. If that path goes down, the firewall can use the priority or the preference of the static route to divert the traffic through an alternate path. So for example, in this particular scenario, the firewall has got 2 static routes, a route with higher preference going through this router and a route with lower preference going through this router. And since IP link feature is configured or enabled, if this particular link goes down, the firewall will detect that this link is down. Therefore, it will increase the preference, or rather decrease the preference of this link, and the traffic will start being forwarded through this particular router or this particular path. So in this way, the firewall can have a high availability implementation where if one of the paths is unavailable, the other path can be used. The second scenario in which IP link can function is with a DHCP scenario. In DHCP scenario, you can see that the firewall is forwarding traffic through this path, and there is a DHCP server which is responsible, or from which the firewall is getting, or the firewall is receiving, the IP address of the gateway router. So if there is any issue with this link, this means that this link will not be available, so the firewall cannot forward traffic through this path, and the IP link is going to inform the firewall. As soon as the firewall knows that this link is unavailable, the firewall will start forwarding traffic through this alternate path. For example, in this case, this is the PPP over Ethernet path, and the firewall can forward the traffic, and in this case, or in this way, firewall can implement the high availability scenario. And the third scenario which firewall can use using IP link is the hot standby scenario. In this case, for example, we have got two firewalls, firewall A and firewall B. Normally the traffic is being forwarded through firewall A. If this link goes down, firewall will know about this link going down, and using VRRP or VGMP implementation, the firewall can switch the traffic through this alternate firewall. These two firewalls are running VRRP, and they are being managing the groups using VGMP. We'll be discussing VGMP and VRRP in much more detail later on in this module. However, it's simply we should be able to understand that as soon as the firewall A detects that this link is down using IP link, it can immediately shift the traffic, or using the VRRP feature, the traffic can immediately be shifted to firewall B, and the firewall B will then start forwarding traffic through this router towards the internet. So this is another scenario where IP link can help us achieve high availability using hot standby. If we look at the configuration mechanism or the configuration steps, you can see that these are the basic steps that we need to follow. We need to configure the basic firewall settings, we need to configure OSPF, and then we need to configure the hot standby or VRRP or HRP. We'll be talking about this in more detail later on in this module. And then for IP link configuration, we configure the IP link, and then we connect the IP link with hot standby feature, which we just discussed. And these are the steps for configuring the IP link. Let's take a look at the IP link configuration using the command line interface. We have already looked at the IP link configuration using the graphic user interface, and here is the configuration of IP link using the command line interface. As you can see that first we enable the IP link check enable feature, or we just enable the IP link feature on firewall A. Then we name an IP link. In this case, we are naming it as test. So IP link name test. And then we define the destination IP address which we want to track or which we want to check, which means that the firewall is going to be sending the ICMP packets to this IP address or the ARP packets to this IP address outside of this interface. So we are implementing IP link to this IP through this interface. And then if we want to connect this IP link, or we want to use this IP link for hot standby purposes, then we can give the command HRP on firewall A. We can give the command HRP track IP link and then the name of the IP link, which was test, which we configured earlier here. And similar configuration we can do on firewall B as well. We enable the IP link command or the IP link feature. We create an IP link with the name of test. Then we define the destination address of this IP link and the interface, outgoing interface, and then we link this IP link feature with the VRRP and VGMP feature using the HRP track IP-link test command. Once again, as I said earlier, that VRRP, VGMP and HRP features, we'll be discussing them in detail when we discuss the hot standby feature on the firewall. And if you want to test this configuration, if you want to look at the status of this IP link, you can give the display IP link command and it will tell you how many IP links that we have on the firewall and what is the status of different links, or what is the status of that each IP link on the firewall. And if you want to look at the details of this configuration, you can issue the display IP link verbose command. Display IP link verbose command is going to give you a lot of details about the configuration, and you can see that what is the status of these multiple IP links and what is the status of each destination within these IP links. So you can see that the IP link state is up and the destination is reachable. So this is how you configure IP link and how you use IP link for implementing fault tolerance or implementing hot standby within your infrastructure. A similar feature which is similar to IP link is BFT, which we will discuss in the next video.